Hi, my name is Randy Iliff, and I'd like to take a few minutes and introduce you to a fascinating tool called Zen-squared. It turns out that people are really good at seeing things, and there's all kinds of things out there we can look at. Things can be pretty much anything. Objects, people, process steps, devices in a circuit card, organizational elements, pretty much anything you want to consider. Collecting things is easy. Making lists of stuff, super easy. But understanding how they all interact and what they do as a set can be maddeningly difficult. Things are only part of the story, because things interact with other things. The vast majority of those relationships aren't all that meaningful to us. They're either below our perception of impact, or they're far away in space or time, or they're just unrelated to us in some way. On the other hand, everything else defines our world, even if we never even realize those relationships exist. Relationships need equal status. The elements need relationships in order to create the task, design, or device that we seek. The parts by themselves don't do anything. It's only when the parts are hooked up in a particular manner that we get the behavior or the process we're seeking. Elements have protective parents with direct interest in their success. In an organization, sales, engineering, project management, finance, they all have their own organizations and structures. Same things with devices. All of the parts have an owner and a manager and a supplier. But the connections between them are kind of orphans in many cases, and they can often end up unguided, unsupported, unappreciated, and generally not as managed or exploited as the elements that they're connecting. So there's a reason that attention is needed in this space. If essential relationships are missing, the product, process, or venture will fail. If useful relationships are missing, then a key source of value is lost, and in a competitive market that can be pretty damaging. If unacceptable relationships occur, though, the most serious consequences are present and people can be injured or even killed. So mind maps are a great way of seeing some of the relationships we look at, a minimally structured representation of the known relationships among elements. They're easy to start, easy to add to, interact with, and explain. A little simple graphic here on the slide gives you a sense if you can throw anything up there and start drawing lines between them. And it's a neat tool, and there's lots of great things about maps, but sometimes you need a reality map instead of a mind map. Mind maps are great for exploration. They provide open-ended scaffolding for thought, but there's really not an expectation that they will ever be complete and pure. Zen-squared, on the other hand, though, lets you describe and optimize all of the elements plus all of the possible relationships. It's deterministic. You'll know when you're done with the tool and how far along you are at any point. And it's efficient because it prioritizes the downstream analysis and lets you make decisions about which pieces you want to work on in what order. A mind map is a little bit more random and unstructured. The Zen-squared tool is one that adds a little bit more focus. And as a result, they're complementary devices. Both of them belong in your toolkit. So what is a Zen-squared matrix? Well, first off, as we've mentioned, it's different than a mind map. A Zen-squared matrix is a structured representation of the complete element and relationship set. That gives it a kind of a power that's not available through the conventional mind map. Zen-squared offers a visual interface to the database of interactions that exist within any set of elements. It's a very simple tool, but it requires knowledge of a few basic rules and terms for people to be able to use it as part of an organizational structure. So we can place what's called a stone. The terminology in Zen-squared is selected to try to be as inclusive as possible. It is very easy for school children to use these matrices, but they can also be applied by advanced aerospace engineers. That range is interesting. But anyway, we'll take a single stone, and that will produce a one-dimensional garden. Things can come in, things can leave. What goes on inside the stone is invisible. So here's a picture of that. In the middle of the slide here is just a stone, and stuff goes into it, and stuff leaves. Not terribly exciting at this point, but everything starts with something simple. When you add another stone to it, something really interesting happens. Now, instead of just one, we see 4 external relationships. From the first stone, which has an input and output, and also the second stone, which has inputs and outputs. But there's something new. Now there are internal relationships that exist because there's more than one stone inside the system we're exploring. These 2 internal relationships are the forward path from the first to the second and the reverse from the second back to the first one. So we can account for symmetry in the relationship, or we can account for things that are different going one direction than the other. So when we add yet another stone, we end up with a larger garden, and we have a lot more interfaces, and we have a lot more inputs and outputs. And with 3 dimensions, we have 6 external relationships and 6 internal relationships. What's going on here? Well, it turns out that the external relationships scale linearly, so the stones times 2. The internal relationships scale exponentially, stones squared minus the number of stones you have. As a result of that, the exponential term quickly dominates the total. And that means that as the systems get larger and larger and larger, individual elements shrink to a point of insignificance, and all of the work, all of the complexity, all of the challenge is found in the relationship set. And that's why Zen-squared is such a powerful tool to add to your toolkit. So when we look at this and we look at larger systems, we're really staring the infinity right in the face. With 4 stones, we get 20 relationships. With 10, you get 110. So when an organization goes from 4 people to 10 in its growth curve, it now has 5 times as many internal relationships that could be a source of either power to the organization if they're going well, or challenges and growing pains if they're not. When that organization goes to 100 from 10, it's now 1,000 or 100 times more difficult to work with. So as you see, as you go up these numbers, if you had 1,000 parts in a device, or if you had 1,000 people in a business unit, there are potentially 1,000,000 plus interactions between those that could either be a source of value or a source of challenge to you. Many of them will be irrelevant, of course, in the real world, but the potential is there that all of those could be important to you. And when you get up into the millions, such as happens with social networks or other infrastructure systems, you can end up with a quadrillion possible relationships. Now, that's not going to be something a human being sits down and goes through one by one by one and gets through in a lifetime. But when we look at artificial intelligence adding to the capability of design, engineering, all kinds of other tasks, looking at a quadrillion things isn't nearly as impossible as it might have been in the past. But the point here is that as a system grows, even from fairly small things to things we might not think of as large, the invisible set of relationships are becoming vastly more complicated. Going from 10 to 100 to 1,000 doesn't seem like that big a change, but we're going from 100 to 1,000,000 in the number of relationships that are involved. So what can you do with Zen-squared? Well, you can document things, you can optimize them, you can evolve them, you can explore them, all kinds of cool stuff. Pretty much anything that relationships are involved in, this is a handy tool to have around. When you use Zen-squared as a database, it's able to hold valuable system information. All of the elements, all of the relationships between them, all of the elements, and because you have all elements and all relationships, every possible flow or sequence that exists amongst those relationships is also present in that database. It can offer you a guide towards mastery. It organizes the information you have at the moment, and unlike a mind map, it shows you where the information you don't have is and lets you prioritize how you want to go acquire that data. So you have efficient access to information. There are lots of answers you can get from a matrix once it's been filled in. You can say what patterns are present. Like any other field, patterns are used to simplify analysis and to help you jump to useful conclusions more rapidly. They're very easy to see in a Zen-squared matrix. You can also figure out what behavior I should expect from the system. Another really valuable one is understanding how much do you really know about a product, a venture, or a particular circumstance. A mind map won't tell you that, but the Zen-squared map will. There are 2 very common questions that come up. If I change one element of the system or one part in a device, what gets impacted? Anyone who's ever run changes in an engineering environment knows exactly how difficult it can be to chase down all of those relationships and linkages. A Zen-squared matrix stores them all. You can change any part in a system and you can see exactly what it impacts from that. You can also then describe what all of the stuff in the black box does without necessarily having to go into all of the gory details of what each part and piece does. And that's enabled by the fact that a single row and column contain everything you need, and you can safely ignore everything else. When you say what else is impacted, I can take a single stone in the matrix, and I have all of the inputs and all of the outputs for that particular stone visible, and then I have all of the internal relationships that go to that stone visible. I can safely ignore everything else in that entire matrix and make confident decisions about what will happen if I change or alter that part. When I want to see what the whole system does, then the outer border is what I look at. I'm ignoring here all of the internal relationships so that I can concentrate on the outside. If I don't care what's going on inside the box and I just want to hook it up into a larger system, this type of view can be very useful. So what Zen-squared offers you is the ability to zoom in and out as your circumstances need. You can get as much resolution as you need to finesse a detail, and then you can scale back all the way to the level of an entire system or an organization or team if you want to see it that way. Common applications of Zen-squared, and these are just a few. Opportunity exploration, particularly in Internet of Things, where relationship drives all of the possibilities. Zen-squared is an extraordinary tool for looking for new venture opportunity. Competitive analysis, you can see how your devices, systems, products, or services relate to others and look for the competitive benefits. You can also see possible synergies and direct competition that you have to go to war with. Engineering design, this is the classic origin of the N-squared or Zen-squared type methodology, is to be used in engineering design, primarily for interface control, interface management, flows, control systems of all kinds lend themselves very nicely to this. And of course, interface control, whether that is done in organizations or elements or parts of a system, it's kind of a specialty form of itself. Organizational structures are also elements and interactions. As I've been very pleased with how effective it is to apply Zen-squared to the design of an organization so that the accumulated history of boundaries between business units or organizations or staff can be examined and see if they make sense given the reality of the work. And it's very often the case that it's possible to tune up those boundaries and align things a little bit more clearly once they're completely visible as a system than has ever happened in the history of the company up to that point. As team development, every team, whether you're talking about sports or business or anything else, is a function of the talent that exists in the individuals, then the talent that exists and emerges as a result of the team. Teams are supposed to be much more than the sum of the parts. If you're not getting that, a really good thing to do is to take a look at all of the relationships that exist between all of the members and make sure that they're healthy, not dysfunctional, and that they're wired up so that they can contribute to the output. Anyway, lessons learned capture, knowledge capture. This is a huge thing that you can do with the tool because it forces people to ask questions and then gives you a place you can document the answer. So if you have perhaps an aging workforce or a generational transition taking place in your world, this is a great way to set down the people who have done it forever with the people who have a little bit less knowledge or moving into those spaces, and to do a really good structured overlap and debrief, but to do so not in a way that just ends up being lost at the end of the meeting, but in the way that ends up with an actual record of what took place so that everybody can build on it and use that as a reference going forward. So anyway, there are tons of applications of Zen-squared. It's been used to figure out why devices at the South Pole aren't doing what they're expected to when they're drilling into deep ice. It's been used to produce new products. It's been used to design aerospace systems and equipment. It's being used right now to alter the organizational structure of a couple of major corporations. So there's a real richness to this. I would encourage you to think of any place that relationships between anything you can think of exist. There really aren't that many classes of tools that are powerful in this space. This is kind of almost an Excel for relationships and ideas. Anyway, thanks for listening. I appreciate your time. If you have any questions, please feel free to ask them, and I will do my very best to answer them as best I can. Thanks for thinking. Bye-bye.